Hello, the question says the table shows the educational attainment of the population of Mars ages 25 and over, expressed in millions. Find the probability that a randomly selected Martian age 25 and over has completed 4 years of high school only, or is a male. So first, let's take note of the keyword here. This is probability with or. And let's take a look at the table and what it describes. We have two rows. The first row is the population of males. That's the total. The second row is the population of females. Then we have in the columns, we have four different columns. The first one is high school, those who completed less than 4 years of high school, right here. And then those who completed 4 years of high school only, right there. Then those who completed some college, less than 4 years of college in this column, and those who completed 4 or more years of college right here. Now, the first thing we have to determine is whether this is two events that are mutually exclusive or not mutually exclusive. This is describing those who completed 4 years of high school only, which is this one, or is a male, which is this one. So when we look at the population of males right there, and we look at those who completed 4 years of high school, which is right there, we see that there is some commonality. There are 30 million who are both. So this is common. They are both male and completed 4 years of high school, which means we need to use the concept of probabilities of two events that are not mutually exclusive. So for events that are not mutually exclusive, and the concept is that the probability of event A or B, keyword is or, and it equals the probability of event A happening plus the probability of event B. Because it's or, we're adding the probabilities, but then we also have to take away or subtract those that are common in the two events. So we have to take away the ones that are overlap between event A and B. So that way we don't double count them. And that's these 30 million right here. Those are the ones that we have to subtract. Okay, so let's calculate the probability of A, or let's rewrite it in terms of what we're asked in this problem. So the probability of 4 years of high school or is a male. So that would have to equal the probability of 4 years of high school plus the probability that this person is a male minus the ones in common, or the ones that are both 4 years high school and male. So to calculate the probabilities, we will start with the probability that this person has 4 years of high school. So we look at the column for 4 years of high school, and we find that the total population or total people that have 4 years of high school is 59 million. So the probability will be 59 divided by the total population, which is 157. So that would be 59 over 157 plus the probability that the person selected is male. So we look at this row right here. We have 79 total males out of the total population, again, which is 157. So plus 79 over 157. Then we have to subtract the common ones, the ones that both have 4 years of high school and male at the same time. So the intersection between this row, this column, and this row is right here. So there's 30 that are male and have 4 years of high school. We have to exclude or subtract those 30 out of the 157 again. So minus 30 over 157. So we add all of this up. This is adding and subtracting of fractions. As long as we have the common denominator, we can write all of that over 157, and we would combine the numerators. 59 plus 79 minus 30, and that would be what we have in the numerator. So 59 plus 79 minus 30, and that gives us 108. Now we would try to simplify or reduce as much as possible, but if there's no reducing or simplifying of this fraction, then this would be our final answer, and that would be the answer to this problem.